Hello guys, welcome to this video on solutions to problems from IIT JAM 2020, questions from reanalysis section. So I've tried to do this in different sets. This is the first set of some problems from reanalysis section. So in this section we are going to see basically 4 questions. These are the 4 questions and I've given the question numbers as per the question paper which is uploaded in IIT website. The remaining sets you can get from the I button which is displayed on top now. Okay, so let's move on to the first question. So here we have a question in which we are asked something about a sequence. We given a sequence Sn 1 plus minus 1 power n by n, where n is a natural number, and we are asked whether this sequence is basically monotonically increasing, decreasing, or convergent or divergent, whatever it is. So it's actually basically a simple question. If you just list out for example, for n equal to 1, you can find that S1 is basically 0, and if you put n equal to 2, you can get S2 as 1 plus minus 1 square by 2, which is 1.5, and if you put n equal to 3, you can see S3 is 1 plus minus 1 power cube by 3, which is in fact 0.667, and S4 is, sorry, it's not S3 here, it's basically S4 here. S4 is 1.25. So it's basically like an oscillating sequence. And one thing what you can see here is that if you take all even numbers, you're getting a sequence, subsequence basically, which is slowly moving towards 1. You can see when you give n equal to 2, you get 1.5. The next number, when you give n equal to 4, you're getting 1.25, and when you go for the next one, it's going to be further smaller to 1.25, but it is approaching towards 1. And when you take the odd natural numbers, you can see it is first 0, then it is 0.667. The next number, if you find it, you can see it will be much more nearer to 1, and so on. So what you can see here is nothing but these two subsequences we are getting here are basically monotonic, and for even natural numbers we are getting a monotonically decreasing subsequence, and for odd natural numbers we are getting a monotonically increasing subsequence. So, and both the subsequences basically are converging to 1. You can simply find the limits here. If you find limit n tends to infinity Sn, you can see it is actually limit n tends to infinity Sn is basically 1. So in this question, it is the sequence as it is not monotonic, but it has basically monotonically increasing and decreasing subsequences which are converging. So here you can see in this option, first option says that monotonically increasing and is convergent to 1. It is not actually monotonically increasing sequence, right? It is just like an oscillating one, so it is not true. Same way, option B is also not true because it's not monotonically decreasing either. And but here option C is in fact true because it is neither monotonically increasing nor monotonically decreasing, but it is convergent to 1, because we got that it is oscillating and oscillating to on the two ends of 1, and basically at last converging to 1. So in this question, option C is true because we are getting exactly a sequence which is actually converging to 1. So it's basically a simple question. We'll move to the next question. Here is another a bit more simpler question given to us, that which of the following is false. So if you go on finding the limit values, if you take the first problem, you can see it is limit x tends to infinity x by e power x, and it is actually basically in infinity by infinity form. So you can use L'Hopital rule and just differentiate on top and bottom. You get 1 by e power x, and you apply the limits, you get the value as 0. So basically what is given to us here is correct statement. If you check option B, limit x tends to 0 plus 1 by x e raised to 1 by x. So this we can rewrite something like this: 1 by x by e raised to 1 by x. Again we have the same case of infinity by infinity form, so we can just differentiate and on both numerator and denominator, and once you do that, you can cancel out these terms, and what you get is 1 by e power 1 by x, which is again x tends to 0 plus goes to 0, because you can see 1 by x goes to infinity, and e raised to infinity again will go to infinity. So 1 by e raised to infinity will again go to 0. So option B is also true. Now if you take option C, it is actually again a bit simpler. Limit x tends to 0 plus, you can see it will approach to 0 by 1, that is 0. So it is also correct. But if you take the last option, limit x tends to 0 plus cos x by 1 plus 2 is nothing but it will be something like 1 by 1, right? It is actually equal to 1 but not equal to 0. So this option is actually the false one. So answer to this question is basically option D. So the next question is to find out the radius of convergence of the power series summation n equal 1 to infinity n plus 2 by n whole raised to n square x power n. So we are given 4 options out there and we are asked to find out which one is the radius of convergence. So here we are going to use this relation for the radius of convergence r. 1 by r is taken as the radius of convergence. So 1 by r is limit n tends to infinity mod a n power 1 by n. So here we have a n is nothing but n plus 2 by n whole power n square. So if you just apply this limit, what you're going to get is limit n tends to infinity n plus 2 by n whole power n, which you can in fact rewrite in this form, that is 1 limit n tends to infinity mod 1 plus 2 by n power n, and which is in fact nothing but e square, because we know that limit n tends to infinity 1 plus x by n whole power n is e power x. So we can just, how do you do this? Simple, just like you just expand it using the binomial theorem, and you apply the limits, you end up in the expansion of e power x. So that is a thing there. So 1 by r we got as e square, so r should be 1 by e square. So option D is true here. So here the radius of convergence is actually, this power series is basically 1 by e square. Now it is a last question in this set. It's actually an interesting question. In fact, it's actually a result which you can see in most of the books in Fourier analysis. So here we are given that an is a sequence of positive real numbers, and limit n tends to infinity an plus 1 by an is L. So we are asked if the following are true. That is, if L is 1, limit n tends to infinity an is 1. If L is 1, then limit n tends to infinity an is 0. If L is less than 1, then limit n tends to infinity an is 1. Or if L is less than 1, then limit n tends to infinity an is 0. So basically, first what I'm going to do here is I'm just going to prove that, or I'm going to just check the case where we have L is less than 1. So we have this result given to us, and we are going to check whether either which one of this is true if L is less than 1. So we assume that L is less than 1, and since we have this an is a sequence of positive real numbers and this limit is existing, we can say that L is basically greater than or equal to 0. So let us choose r as a number such that L is less than r and less than 1, and we'll choose epsilon to be r minus L, obviously greater than 0. Now we know that since this limit is existing and it is equal to L, there exists a number k belongs to set of natural numbers such that for all n greater than or equal to k, we have mod an plus 1 by n minus L will be less than epsilon. So this is possible to find by the definition that we have. So if n is greater than or equal to k, what we can tell is, just bring this this we can rewrite as what, minus epsilon less than an plus 1 by an minus L less than epsilon. You add on both sides capital L, small l, then you get L minus epsilon less than an plus 1 by an less than L plus epsilon. So we are using an plus 1 by an is less than epsilon less than L plus epsilon, and this epsilon we have chosen as r minus I, so it becomes L plus r minus I, which is equal to r. So yeah, this is not capital L, this is small l. Yeah, so now this, if you just multiply an out here, you get, what you get is an plus 1 is less than or equal to r times an, right? Similarly, what you can derive is something like this. This we derived from the first section, that is an plus 1 less than an by r. Now if you're going to write this thing in terms of an minus 1 and an, then from that you can in fact derive this, that is an r less than an minus 1 r square and so on. So here if you are going to set c as ak by r for k, then we can see that 0 will be less than an plus 1 is less than c power c into r raised to n plus 1 for all n greater than equal to k, and we have chosen r to be greater than 0 and less than 1, and so it follows that limit n tends to infinity Rn will be equal to 0, because we have chosen r to be value between 0 and 1, so limit n tends to infinity Rn has to be 0, which again you can I think you know these things. And since it is an plus 1 is bounded by that the sequence, so limit n tends to infinity an has to be again 0. So that means we got the implication that if L is less than 1, then limit n tends to infinity an is actually 0. So this basically is a result available in the textbook, you can see. So that means option C and D, from option C and D, option D is true. But again, if L is equal to 1, what we must do is the second question. So for that, I'm just considering a sequence an, simply n, of positive real numbers. You can see L is nothing but limit n tends to infinity n plus 1 by n, which is limit n tends to infinity n plus 1 by n, which is just n times 1 plus 1 by n by n, and then gets cancelled, and you apply the limits, you get the value as 1. So L is 1. So we have just chosen one example in which limit n tends to infinity n plus 1 by n is actually equal to 1, or equal to L, which is 1 as per whatever is given to us here. You can see L is equal to 1. So I am choosing such an example. So in that case, you can see we got an example for which it happens, but the limit n tends to infinity n is basically going to infinity. So that means option A and B are not at all true. So that is the implication what we're getting from here, and so option A and B are false. Obviously it is actually, all these problems are from MCQ section, so basically you may have only one answer, but still if you want to just have a reference, you can see here and how we can show that A and B are also false. So thank you for viewing this video, and for other sessions, other sets of real analysis questions which are asked for IIT JAM 2020, just please refer the playlist available here, or you can click on the I button top there, or you can visit my channel for getting the further videos. Also, I'll request you to subscribe my channel for getting further videos.